Hello and welcome to fresponse.com. Today we're going to talk about the new fresponse version 7, specifically under Tactical. We've chosen the Sans Sift kit to do this demonstration. So essentially what we're going to do is we're going to get our fresponse packages installed. In a divergence from historical fresponse Tactical, we do actually now require some software to be installed on the Examiner machine. So what you see here is us going through the commands to go ahead and set that up and to deploy to configure the software on this Examiner system. We're also going to go through and make sure any additional dependencies are installed and prepared. All of these instructions are available on our website, so don't worry about copying these down now. The next thing we need to do once we've installed fresponse Examiner software on our machine is to go ahead and set up the varlib fresponse folder. That's where we're going to keep all of our configuration information and details while the application is running. So we're going to make sure it's owned by our user account. We're also going to make sure it has the appropriate permissions. Next thing we're going to do is look for Fuse. Fuse tools are what we use under Linux to map fresponse targets now. It's a little bit different than we used to do before, but this gives us a lot more flexibility. So these commands are what we use to make sure our user account can execute the Fuse tools and to make sure Fuse is configured to accept changes from our user account. So once we've done all of those things, we'll be able to then go into the software and take a look at it. Like I said, this seems like a lot of information to go over, but we really only have to do this one time. The first time we would use our Linux machine to do examination for Tactical. Another departure for Tactical under Linux is that we now use something called the accelerator. People who are comfortable with or have used other versions of fresponse are familiar with that name. For Tactical customers, it's a little new. This new graphical interface gives us the ability to connect to tactical targets. So the first thing we'll do once we open up is go to the Tactical panel there and select the scan option. So what that's doing is it's locating the Tactical Examiner device on our machine. And once we've done that, now let's go over to our subject and get that started. Alright, so here we are on the Tactical subject. You can see that we've got our subject dongle inserted, and we'll go ahead and execute the Tactical software on that machine. We've got a new little messages window here, so if we do have additional errors or issues or problems that come up, you'll see them appear in that messages window. Now that we've got it started on the machine, let's go back over to our Linux machine and take a look at it. Just like before, what we have is we have a mechanism for connecting directly from the Examiner to the subject. So what we're going to do is we're going to select our Examiner device, and we're going to use that Examiner device to locate our Tactical subject. And you'll see it was listed as successful. Under Subjects, you'll see the remote machine along with all of the details about it. Selecting that machine gives you a list of targets. Now we can select any individual target and then mount that target. In this case, we'll go ahead and select Volume C and Physical Memory. Mounting targets under Tactical looks a little bit different than it used to. We're going to create folder-based mount points, and each mount point is going to have an individual live file in it. So you can see here under our desktop we have two directories, each of them falling under the subject's name, one for Volume C and the other for Physical Memory. Now we're going to go open up a terminal window and take a look at that. What we've got here is we've got the two directories, and inside these directories we have a series of live files. There's a live file under Physical Memory and a live file under Vol-C. Those live files, think of them like direct access to the raw physical device. You can see based on their sizes that they match the size of the remote machine's physical disk. In order to access these devices as actual disks under Linux, we're going to use something called loopback. So what we've done here is set up our used LO setup to create a loop device. We're calling this dev loop 0, and we're pointing that loop device at our Vol-C live file. So what this does is now we have dev loop 0 on our machine. According to Linux, it sees that as a new physical device. We're going to create a mount point called Vol-C, and we're going to use the mount command to mount loop 0 as a mounted volume. Thanks to the Sift kit, we have NTFS file system controls so that we can go to this volume, we can double click on it, open it up, and see the file and folder content. You'll see that the individual files are marked as locked because we're looking at a read-only device. but this gives you the flexibility to extract individual files should you want to. Next, let's go ahead and take a look at the physical memory. We can go through the same processes we did before if we wanted to mount it as a device. However, what's really exciting is that we can access this using Volatility directly. Volatility, if you're not aware, is a great command line tool in the Linux environment for doing physical memory analysis. Since we know our remote machine is an older Windows XP machine, the first thing we're going to do is take a look at what profiles are available. These are volatility-based profiles for the physical memory of the remote machine. We'll go ahead and execute Volatility. We'll point it at the profile specific to that remote machine, and then we'll point all of it at the file, the live file that we have that represents physical memory on that remote machine. So what's going to happen is that Volatility is going to read from that machine. It's going to analyze and in this case return a process list in real time from that remote machine. So here you can see all of it, including our own FResponse tactical executable. So as you can see, this gives us a lot of flexibility. Really the same kinds of things we could do under tactical before, but now in a much in a more graphical interface, in a slightly easier to consume package. So now we'll back through the process of unmounting and removing those individual volumes. We'll go ahead and remove the loopback device, and we'll go ahead and clear the system. We can return to the accelerator, open it up, and then detach the two targets that we have currently attached to the machine. All right, if you have any questions, we can be reached on our website at www.f-response.com. On the bottom of every page, there's a support chat, and we're here and happy to help you. In addition, you're welcome to send us an email at support@f-response.com. Thanks, and have a great day.